we on? Can anybody see or hear me right now? All right, testing. Give me a 2 in chat if you can see or hear me right now. We're live. All right, thank you, Lenina. Welcome, Claire Burr, Lenina Mudman, Rahab Olam, Trek Nerd, Smorphosaurus. How you doing? Welcome, everybody. Apologies about the wind. I'm outside right now. I'm here in Kenosha, Wisconsin, and we are about to go take a tour of the Dinosaur Discovery Museum here in Kenosha. And there it is right back there. I already went for a little stroll around the inside, and holy cow. If any of you like theropods, this is your stream. You're going to have a great time. Yeah, never have I seen so many large, beautiful theropods all crammed into such a small space. This is it's going to be pretty spectacular. So I hope you're ready for that. But yeah. And hey, Actual Dag, Green Herring, Lone Mountain, how you doing? Wonderful to have you here. Yeah. This is going to be super, super cool. I know a lot of my streams have been kind of theropod heavy because I'm working on theropods right now. Well, we're going to see one of those ones that I'm working on there in the museum. I've never actually seen a mounted specimen of this particular critter, a Spinosaurid. We're going to see a Suchomimus up close and personal, and I am so excited to show you that. So, yeah, what do you say when we get to it? And hey, Valent, how are you doing? The SciComm legend is here. Are you announcing your own presence there, Valent? How are you doing? It is great to have you here. Welcome to Paleontologizing. And shoot, I should introduce myself real quick. If anybody is here for the first time, if you're wondering what's going on, my name is Danny Anduza. I'm a dinosaur paleontologist. I dig up dinosaurs, I study them, and I talk about them full time here on Twitch now. Right now I'm embarked on this great big road trip going all across the US, visiting different museums and field sites, and streaming whenever I can. Right now I'm in Kenosha, Wisconsin, and we're going to go check out this awesome museum. Yeah. Later on in the summer I'm actually going to be doing some dinosaur excavations down in Utah. And yeah, I'm pretty excited about that too. I'll be streaming that as much as I can, provided that the equipment all works properly. So, first of all, what a lovely facade for a museum here. This is Kenosha Public Museum up there. So you can visit this museum free of charge. I think they might have partial municipal funding. I think the museum might actually belong to the city. So this belongs to the people of Kenosha, which is pretty cool. Never been here before. It's my first time, and I'm very excited. I think this maybe used to be the municipal post office. It's a lovely old building, and I was looking at a little display here about how they actually moved it. It used to be at a different site, and then they picked up the actual building and moved it here. It reminds me of, I don't know, kind of your picture-perfect museums from popular culture. I don't know, the museum from, what was that game, Animal Crossing? Kind of reminds me of that. So yeah, pretty neat. Yeah, let's go ahead and get in there. I've got a lovely theropod right there. A pretty stylized one, but pretty cool. Let's go right up to the door. And all right, so I'm going to be talking softly this whole time so as not to be obnoxious. And normally under these circumstances I'd be wearing a mask, but I know that there are some people who are hard of hearing and they wouldn't be able to tell what I'm saying if they can't read my lips. So I'll be forgoing a mask because of that. But just know, normally I would be wearing a mask. There's the main hall, which we'll be looking at in a few minutes. But right now, let's check out some of these displays over here. Definitely geared toward kids, but pretty neat. It's a lovely, looks like a Hell Creek environment right here. pretty neat. Triceratops, aka Torosaurus. Yeah. Oh, and outcasted. Fish person from the zoo. I'm on lunch at work. Well, welcome. Great to have you here. Wonderful. Is this Graham or is this Taya that I'm speaking to right now? Let me know. And can everybody hear me, by the way? I know I'm whispering, but this is supposed to be a pretty good microphone. You should be able to hear me, I hope. Yeah. Check this out. Got some nice displays with feathered dinosaurs here. We're just gonna kind of cruise through this. Yeah. And, oh, it's actually summer. Oh, okay, cool. Yeah. Hearing is fine? Thank you, Tarquin. And thank you, Tiny Blep. Oh, gotcha, Taya. Okay. Well, cool. I will call you Summer then, if that's what you want to be called. Welcome back, Summer. It's great to have you here. Cool. We've got more people coming in. Yeah, so this is actually the museum of Dr. Thomas Carr, who's a dinosaur paleontologist who specializes in Tyrannosaurs. We'll see his name throughout here. I even saw a little cartoon representation of Thomas Carr. Yeah, I've never actually co-authored any papers with Thomas Carr, but that might be changing at some point in the future. Yeah, especially as I continue to work on theropod dinosaurs. Yeah, this is a model of what paleontologist Dr. Thomas Carr thinks little Clint might have looked like when he was just 3 months old. There we go, little baby Tyrannosaur there, and this is lovely, with those forward-facing eyes. So Tyrannosaurs like this would have had excellent depth perception. And look at those long, lanky legs. One of the common questions that I get from people is, how fast could T-Rex run? And I usually answer that with another question, which is, well, what age T-Rex are we talking about? Tyrannosaurus is a dinosaur that went through tremendous changes in its ontogeny. So from the time that it was, when it first hatches out of an egg, it's very small, smaller than this. So this critter would be about 3 months old. They hatched out of an egg no bigger than, I don't know, a volleyball or something like that. Probably a more elongate egg than that. So what would be a better, let's say an egg the size of a loaf of bread, maybe, that you might pick up at the grocery store. That's about the size of a Tyrannosaurus egg, most likely. We've never actually discovered any Tyrannosaurus eggs, but from other related theropod dinosaurs, we know that's about the maximum size for their eggs. So the critter has got to go from that big, the size of a loaf of bread, to an animal 40 feet long. That's a huge change in size. And also their proportions would change a lot too. So as you can see from this model, they had very long legs like that when they were really young, and early on they were probably pursuit predators. These would have been very fast, very agile animals. But as they continue to grow and mature and bulk up, they would get a lot bigger, a lot heftier, probably a lot slower. So how fast could a T-Rex run? It depends what age we're talking about. A young one could certainly outrun you, and I don't know, maybe it would be about as fast as an ostrich. Who knows? But when it's full grown, probably couldn't run quite as fast. And it wouldn't need to. An animal that big and strong, if it's going to be an ambush predator, it could be very successful doing that. Maybe it didn't even have to hunt very much at all, and could just bully smaller carnivores away from their kills, mostly other smaller tyrannosaurs. So yeah, anyway, how fast could T-Rex run? Depends what age they are. Here's a young one with those super long legs. This would have been a speedster.
Hi everyone.
Yeah. And Hugan says they went from Flash to Juggernaut. Is that a superhero reference? I just barely got that, I think. But yeah, good analogy. I like that. Yeah. I love these displays over here. These are really neat. Talking about the environment that small tyrannosaur would have lived in. This is informed by Thomas Carr's fieldwork. I ran into him last summer in Ekalaka, Montana, down in the southeast corner of the state. I think he was about to do some field work there, and he was attending the Dino Shindig in Ekalaka. And this is like a kid's dig area. It's closed right now. Right here, look at this. Got a lovely jacket with a big old femur in it. Yeah. This looks like doesn't look like a tyrannosaur femur.
With sincere appreciation,
it's either a Edmontosaur or a trike. I'm going to say it's a trike based on the shape. Edmontosaurs tend to have kind of rounder femurs in cross-section. So I'm going to say this is from a Triceratops.
And understanding of fossil science.
This is the largest bone in the animal's body, if you don't count the skull as one bone. Yeah. Thank you, Orchid Twilight, for, holy cow, the 2,000 bits. Really appreciate that. Thank you for your support. Yeah, holy cow. Yeah. And it's very difficult for me to keep track of. I've got no indication of hype trains or anything on this right here. So yeah, but thank you so much, everybody, for your support, especially you, Orchid Twilight. Holy cow! Sazla Shake says that's a big bone. Yeah, it's a femur. It's the largest bone in a Triceratops body. Again, the skull being comprised of multiple bones. If you counted the skull as one bone, then that would be the biggest. But it's not one bone. It's made up of a bunch of different pieces.
Appreciation and understanding of fossil science here.
And this is a field jacket. So this is the kind of protective cocoon that we put around these bones in the field in order to preserve them and protect them, bring them back to the laboratory. So it's interesting that they've used aluminum foil here as separator. Yeah, my crews, we always used damp paper towels.
1,000 bits can make a wonderful
difference. Seem to work a little bit better than aluminum foil.
And understanding of fossil science here.
It's cheaper. We're always operating on a shoestring budget. So, yeah, paper towels are where it's at. Also, the nice thing about having a roll of paper towels in your bag is that when you're out in the field and, say, during the hottest part of the day, everybody wants to sit in the shade and cool off, you can use that paper towel roll as a pillow, basically. So, yeah. Anyway, yeah. I'm sure we'll be making plenty of jackets in the field later on in the summer, so stay tuned for that. I'll give you a step-by-step instructional guide on how to make your own fossil jackets. Yeah. And thank you, Orchid Twilight. I really appreciate that. An additional 2,000 bits. Holy moly. Level 5 complete. Holy cow, everybody. Thank you for your support. I really appreciate that. Holy cow. Here, we're going to go head downstairs and see some of the stuff down there real quick. Then we'll go into the main hall where we've got all of these beautiful theropod skeletons, casts of them all arranged. Again, I've never seen so many big theropods all in one place. It's going to be pretty cool. But for right now, let's go down these steps and then check out the let's see. Pardon me? Shoot, did we there we go. Okay, I guess it's not gonna work in the basement. There's not enough signal down there, so I came right up here real quick. Let's go ahead and go into the main hall. Because I guess it's the only area where the signal's actually gonna work. Alright. Check this out. Absolutely incredible. Oh my goodness. Look at all these dinosaurs. All these beautiful theropods here. Everything from one of the largest of all theropods to some of the smallest over there with those little birds. Very, very cool. I am incredibly impressed. Really, really neat. Yeah. Holy cow. And some of you might recognize, let's just start right here with this velociraptor. Check out that skull right there. That is the same exact one that I have in my office. So that is a cast of a velociraptor skull that I got from Bob Gaston down near Fruita, Colorado a few years ago. And you can actually, if you want, I don't know, if you have The inclination
The
of the
ponderous
cache. You can buy your very own
32 feet long and
Velociraptor
14
skeleton
feet
cast
high.
like that. Exact replica of the real
1,500
thing.
feet, and not a single cavity.
As we all know, real fossils, real dinosaur specimens belong in a museum. They belong, in the public trust to be enjoyed and studied and, preserved for future generations. So everything that you see here is going to be a cast, as far as I know. The real fossils here in this museum are going to be down in the collections area.
1,000 bits can make a wonderful difference in promoting the appreciation
But
and
I don't know, if
understanding
you're
of fossil
somebody like me
science
who would
here
love to
on
have
trips.
a velociraptor skeleton in your office or something like that, get yourself a cast like this. That is beautiful. Although right here, interesting. The specimen may be a new genus and species because the skull is different from that of other dromaeosaurids. It's an interesting idea. So they're saying that this is not actually Velociraptor mongoliensis or Velociraptor osmolskae. They're saying that this is a different taxon altogether. Which, I don't know. I'm of the opinion that many of the theropods from Mongolia are probably grossly oversplit. A lot of that variation is probably actually due to ontogeny or stratigraphy, but that's neither here nor there. So I'll just call it Velociraptor for convenience sake right now. But take a look at that, and that is, by the way, actual size. Velociraptor is not a particularly large animal. It's about the size of, I don't know, a medium-sized dog, something like that. Pretty neat. Let's go over here. Oh, Arle, how are you doing? Welcome, Dad. Good to see you. I've got some displays about this. Oh, shoot. Well, I'm the only one in the hall right now. Let's do a dinosaur quiz here. And I'll ask you these questions, chat. First off, true or false, all dinosaurs were huge? What do you say, chat? Type in true or false. Were all dinosaurs huge? I ask you as we just looked at that small velociraptor. Big false. Indeed. Very good, everybody. Very good. Okay. Let's open it up and see. False. Some were very large, but some were also small, no larger than a chicken. If you consider the avian dinosaurs, living birds, the smallest is the bee hummingbird, which we've talked about many times, Melassuga helenae, the smallest dinosaur that's ever lived, as far as we know. They're so tiny it can perch on the eraser of a pencil, or on the end of a penny. It weighs less than a penny, as far as I know. Very good, everybody. Not all dinosaurs were huge. All right. Here comes the next one. True or false? Dinosaurs were the largest animals to ever live. True or false? Were dinosaurs the largest animals to ever live? And hey, Embus, how you doing? Welcome, welcome. Yeah. All right. There's another word that they could have put in there that would have made this statement true, but it is indeed false. Or true and false. Okay, interesting. It says true and false. This is a trick question. The sauropods were the longest land animals to have ever lived, reaching lengths of 42 meters or 140 feet. However, the heaviest land animal to ever live is swimming in the oceans today. The blue whale can weigh as much as 190,000 kilos or 209 tons. So I like that. That's actually better than the answer that I would have given off the top of my head. Dinosaurs were, the longest creatures to have ever lived. Longest animals, at least. And, I don't know. Also, if you go with the argument that, hey, whales kind of cheat, Whales are essentially weightless because their weight is buoyed up by the medium they live in, by the water. So, I don't know. If you think about it that way, dinosaurs would also be the heaviest animals that have ever lived, too. Except for maybe those giant ichthyosaurs that are starting to pop up. But those are also aquatic, so they've got the same thing going on as whales. Anyway. So yeah. And Chuck Nerd says a whale is a horse, so it's a land animal. Whales aren't horses. What? They're hoofed mammals. They're ungulates, but they're not horses. Of all the hoofed mammals, whales actually belong to a different branch of ungulata called Artiodactyla, the even-toed ungulates. So they're more closely related to things like hippos, like, I don't know, pigs and goats, I suppose. Does that make sense? Yeah. Than they are to something like horses, which are odd-toed. They only have one toe. Anyway, true or false, dinosaur is the name for any animal that lived millions of years ago. True or false? All right, here. Everybody who's ever seen my streams before should know the answer to this. Oh, yeah. And Ogre TV says, what's my favorite Jurassic movie? A movie set in the Jurassic period? Or do you mean like from the Jurassic Park / Jurassic World franchise? It would have to be the first Jurassic Park. 100%. Yeah. Unequivocally. Yeah. Yeah. Anyway, true or false? There you go. It is indeed false. So during the Mesozoic era, there were different clades of reptiles, mammals, fish, and invertebrates that lived on land and in the water. I get the impression that maybe Thomas Carr actually wrote these himself. They're very carefully worded, they're very thoughtful, using terms like clade. Yeah. But during the time of the dinosaurs, there were many, many other kinds of creatures walking around, running around, flying and swimming and burrowing and doing all kinds of stuff. Dinosaurs are a specific group of reptiles. So think of, life on Earth being a big family tree. Dinosaurs are like one branch or one limb on that tree. So they all evolved from a common ancestor. That's basically how we distinguish dinosaurs from other creatures, is that dinosaurs are every creature that evolved from a single ancestor and then branched off of that. So it's kind of a cladistic definition, I guess, for dinosauria, or a phylogenetic definition. So anyway, that's why birds are dinosaurs, because birds evolved from dinosaurs. That's why crocodiles and alligators are not dinosaurs, because they didn't evolve from that same ancestor. They're more like cousins to the dinosaurs, They're from a slightly different branch on the reptile family tree. All right, true or false? Dinosaurs lived at the same time as people, woolly mammoths, and saber-toothed cats, just like the Flintstones. True or false, everybody? What do you think? Yeah. And Green Herring, I didn't mean movie made in the Jurassic period, movie set in the Jurassic period. And actually, come to think of it, I don't know if I can think of any movies that are set in the Jurassic period. Movies that are set during the age of dinosaurs are almost always during the Cretaceous. Anyway, true or false? Dinosaurs lived at the same time as people, woolly mammoths, and saber-toothed cats, just like the Flintstones. Yep. It is, of course, false, except for birds. True and false. Yeah. Another tricky question. People, woolly mammoths, and saber-toothed cats lived millions of years after non-avian dinosaurs became extinct. Avian dinosaurs, or the birds, have survived for millions of years, living alongside people, mammoths, and saber-toothed cats. So yeah, the last of the non-bird dinosaurs went extinct 66 million years ago. So there's basically, depending on how you count it for the origin of humans, there's between 66 and 64 million years between the extinction of the non-bird dinosaurs and the evolution of people. But yeah. Anyway, next question here, and then we'll wrap this up and start looking at these skeletal casts. True or false? Dinosaurs had tiny brains and were very stupid. What do you think, everybody? True or false? Yeah. Oh, and Ogre TV says, do we know why the crocs survived and the dinosaurs did not? While people are answering this, let me answer that question. We're starting to kind of figure it out. It turns out that when the asteroid hit Earth 66 million years ago, it really did a number on every large animal, basically. Basically, the only animals that survived, for the most part, are small. So dinosaurs, like T-Rex right there, ended up dying out, along with all the other large dinosaurs only the small dinosaurs survived, and only a few of the small dinosaurs managed to survive. Smallest ones being birds. That's why we still have birds today. So yeah. Anyway. True or false, dinosaurs had tiny brains, were very stupid. That's, of course, false for the most part. False. They had the right sized brains for reptiles of their body size. Some, Tyrannosaurus rex, Troodon, you know that guy, everybody, and avian dinosaurs had larger than average sized brains. That's the thing. Like that, it bugs me that people go on and on about, you know, dinosaur brains being small and stuff like that, because dinosaurs were remarkably successful animals. And in the environments that they lived in, they were the smartest creatures around, too. You know, they had the largest brains for their body size. Kids. So yeah. Dinosaurs were significantly more intelligent than our little mammalian ancestors at the time, who lived alongside dinosaurs. So they would have made our ancestors look stupid by comparison. So yeah. Anyway. And the kid's very enthusiastic. There. Oh, I can hydrate here. Let me do that. Oop. Uh-oh. Okay, works. Actually, I did not break that. It's still working. Anyway, yeah. Who can tell me what this critter is right here? We've talked about this beastie a number of times on the channel before. It's been nicknamed the chicken from hell. This critter right here. Anybody know who this is, or what broad group of dinosaurs this belongs to? Yeah. And has helped Snow not stand in the background. This guy right here. This is a giant Oviraptorosaur. I think that's probably Anzu. It's a scenic gnathoid on the side here. Oh, interesting. Okay, that's neat. It says this cast is a composite of two animals found 50 years apart. It is now at the Carnegie Museum in Pittsburgh. The skeletons belong to a new cenognathed species not yet named or analyzed. I'm assuming this is after the publication of Anzu. So this is going to be a different giant cenognathed. From South Dakota. Yeah. Interesting. Somebody can look up the specimen numbers, CM 78,000 and CM 78,001. But a composite specimen means that there's multiple individuals that contributed bones to the skeleton. So right there, there's more than one individual represented here in this skeleton, which is what we call a composite. Pretty cool. And I like how we were talking about this earlier with older displays. Oftentimes, like the replica parts and the actual fossil bones are like painted the exact same color, and it's kind of difficult for visitors to tell apart. Which parts are based on real fossils and which parts are reconstructed. And here, if you look closely, you can tell the difference. Look at the top of the head right there. See how it's painted a different color? That's black, and the rest is kind of a dark brown. And with the arm bones there, the humerus and the radius and ulna, and then the furcula right there are black. And the surrounding stuff is dark brown. The black, smooth stuff is the stuff that's been, reconstructed. And the dark brown stuff is based on real fossil material. Very cool to see. Very, very cool. And the tail especially, I think, is really neat. It's got kind of a pica style going on there. You see how at the end of the tail, the vertebrae are kind of truncated. And, it's just like with modern birds, how they have kind of a Sometimes it's called, I think, a parson's nose. Kind of the little nubbin on the end of the tail. Birds have truncated tails. They don't have long, bony tails. And dinosaurs like this, kind of evolving the same thing independently. These guys are very closely related to birds.
Really?
But they're, it's not like they inherited those features from a bird ancestor, as far as we know.
Generic lambda gifted a tier 1 sub to crystal
Listen to that
alpaca.
all Maniraptorans might be birds, which is a hypothesis that's out there. We don't really know yet. Very cool. Look how big this critter is compared to me. It's a seriously big animal. And they probably mostly ate plants. I mean, they've got these toothless bills like that, toothless beaks. But I don't know. Anytime a dinosaur doesn't have teeth, it does become a mystery. Like, what is it eating? Teeth are often our best clue for figuring out a dinosaur's diet. And when they don't have teeth like this, it becomes tricky to figure that out, you know? Anyway, let me pause for a second and catch up to chat, see if I've missed any important questions here. Generic Lambda, thank you so much for the gift sub. I really appreciate that. Thank you, thank you. Yeah. Yeah, looks like an ostrich, says Lara Croft. And Miko says ratites are modern dinosaurs. They are. All birds are modern dinosaurs. Yeah. But when you look at something like this, it really kind of hammers that point home, you know? Yeah, that if you look at an ostrich or an emu or a cassowary, it's it's very similar to an oviraptorosaur like this in many ways. So yeah. Very cool. Very cool. Yeah. And Cassie K says, what percentage of fossil displays in museums are complete specimens? Very few, yeah. It's very rare that we find anything close to a complete dinosaur skeleton. Normally what we have to do is find like multiple specimens of the same animal in order to get all the parts, you know? But there are a number of dinosaurs where we've been able to do that, including T-Rex up there. We now have every single bone in its body. Not one of the specimens has been complete. Everybody's missing something. Even if they were complete, it can be really difficult to actually collect all of the bits when you're digging them out of the ground. But with Tyrannosaurus, we've got about 50 specimens nowadays. So we finally have every single last piece. Yeah, from different specimens, but, you know, still counts. But yeah. Yeah, anyway, let's take a look at one of these beautiful theropods. So every dinosaur that we're going to see in here is what we call a theropod. Theropods are the two-legged, mostly meat-eating dinosaurs. That includes everybody's favorites like Tyrannosaurus, Velociraptor, and Allosaurus, all three of whom we can see here today. It also includes birds. Birds evolved from theropods. And when we look at a dinosaur like Gallimimus right here, that become, well, you could just really kind of see it illustrated there. Yeah. Check that out. So Gallimimus is one of the larger of the ornithomimosaurs, often called the ostrich-mimic dinosaurs. And Gallimimus itself, the name means chicken mimic. There's kind of a trope with these guys, with the ornithomimosaurs, to have their names end in the suffix mimus, which means mimic. So we've got Gallimimus, Ornithomimus, Struthiomimus, Harpyomimus, Pelicanomimus, Garudomimus, and Ceramimus. Yeah.
Appreciate people examining.
So usually when somebody finds a new ornithomimosaur, they kind of abide by that trope and give it that name. That way, when you hear that name, you know right off the bat that it's an ornithomimid. With one major exception, whom we'll also see. He's hiding over there. We'll take a look at that critter too. I'm very excited to show you. But yeah, Gallimimus. Very cool. Oh, and we've got a rate going here. Well, welcome everybody to Paleontologizing. Holy cow. I'm talking quietly right now because I'm in a museum. My name is Danny Anduza. I'm a dinosaur paleontologist. And I'm currently at the Dinosaur Discovery Museum in Kenosha, Wisconsin. And man, am I impressed by this place. Very cool. They've managed to fit so many different theropod dinosaurs into such a small space here. It's kind of a wonder. I love this. Yeah. Anyway, I'm a dinosaur paleontologist. I dig up dinosaurs, I study them, and now I talk about them on Twitch. This is my full-time gig. Normally I stream from my office back in the San Francisco Bay Area, but right now I'm on a big road trip going all across the US, visiting different museums, different field sites, and later on in the summer, going to be doing some field work and digging up some dinosaurs, hopefully live on Twitch, if the equipment works. So yeah. Who was it who raided? But thank you for the raid. I really appreciate it. Yeah. And no, I can't see or hear the alerts. You're right about that, Claire. All I have to see what's going on is this right here. So, yeah. And Game Grammar, hey, well, thank you for the raid. I really appreciate that. If anybody who was watching before doesn't know about Game Grammar yet, I don't have to check them out. But check out their channel, see if you might want to give them a follow. And thank you, Game Grammar, for the raid. I really appreciate it. My whole raison d'etre here on Twitch is to do science outreach, to talk to people about paleontology, try and give them kind of an inside peek into how fossil science works. So you're helping me to do that with that raid, and I really appreciate it. Thank you. Yeah, let's continue on over this way. We'll take a look at Caudipteryx right there. So again, here is the full hall here. Let's take a look at this animal real quick. That is lovely. I didn't realize it was so big, but that is Caudipteryx. So Caudipteryx is another oviraptorosaur, kind of like this big guy here. Caudipteryx is significantly smaller. And Caudipteryx is really special and important because it's been found, well, for a number of reasons, but the thing that made it really important right off the bat were the feathers that were preserved with the skeleton. So you can actually see traces of those on that fossil cast right there, on this exact copy of the real thing. So if you look toward the end of its tail, it's very short, truncated tail. You can see wisps of feathers right there. And you can also see them along its back and along its arms. So, yeah, in the actual fossil, it's a little bit more obvious. But this one has been painted, this replica has been painted to kind of show you the same thing. Yeah. And this is the earliest member of Maniraptora here in the museum. So, Maniraptorans are the group of theropod dinosaurs that birds belong to. Birds, oviraptorosaurs, dromaeosaurs like Velociraptor and Utahraptor. Yeah. Here, we'll have to check out that video too. I didn't realize there was a video there. I wonder, that almost sounded like Thomas Carr's voice. Yeah. And is that a little Jack model? I think that's supposed to be Charles Darwin right there, actually. Yeah. Which is cool. I really like this. Somebody has some real artistic talent here. I'm impressed. Yeah, that's all handwritten right there. And I think that is a hand-drawn little Chucky D there. Good old Chucky D, Charles Darwin. Yeah, Jack Horner doesn't have a big beard like that. And Jack Horner's not that bald either. Or at least he wasn't the last time I saw him. Yeah. Anyway, very cool. And I like the sounds too. The ambiance is nice. Yeah. And Lenina, thank you. I'll check out my whispers later if I can remember. Yeah. And see films. Thank you for watching. I appreciate your enthusiasm and your kind words. Yeah. All right, let's check out. Sinosauropteryx. Wait, there he is. Yeah. Oh man, very, very cool. So that is a cast, a replica of Sinosauropteryx right there. We've talked a lot about Sinosauropteryx on this channel. This is the first, incontrovertible feathered dinosaur to ever be published. Non-avian dinosaur. Chinese lizard wing is what the name means. Like there, on the side. But yeah, that's the actual size. So it's a little critter. When I show off pictures of that, people call it, the lemur dinosaur or something. Because we actually have information on its coloration. We know that this guy was mostly kind of a rusty orange color, kind of light underneath, darker on top, and had white stripes running down his mostly orange tail. So pretty cool. And there you go, I do have some commands about that. Thank you, Claire. So yeah, Sinosauropteryx, really neat. Yeah. Very, very cool. And then there's a close relative, Compsognathus, right there. Beautiful little skeletal mount. That is lovely. Yeah. And there is one of the famous Compsognathus specimens from Bavaria in Germany. Very, very cool. There's an idea that maybe these guys are actually juveniles of larger dinosaurs, and it's possible. Yeah, I think that's something that I would like to see explored in more detail. Yeah, very, very cool. Give it a roast beef sandwich. There you go. Is that a Lost World Jurassic Park reference? Yeah. How did that go? Hello, are you some little bird or something? Would you like some? It's roast beef, it's good. Anyway, who could tell me who these arms belong to right here? This is very, very neat. Yeah. To whom do those arms belong? A dinosaur that's kind of near and dear to my heart. Some of you have heard me talk about it before. The largest arms from any theropod dinosaur that I'm aware of. Dinochirus, indeed. Very good. And check that out. This is actual size. So that is a cast of the original Dinochirus arms from Mongolia. And, shoot, could somebody find my Prehistoric Kingdom review and post a link to that? Because I tell a whole story about Dinochirus. And, yeah, you can learn about why that dinosaur is, so near and dear to my heart. Yeah, it's such a cool story. Such a cool story. But yeah, thank you, Claire. But check that out. And this is nice because the sign is giving me a better idea of when these displays were put together. So it says here, Dinochirus is thought to be an ornithomimosaurian, the lineage that also includes Gallimimus. So I think that actual paper came out in like 2014 that showed that yes, Dinochirus is indeed an ornithomimosaurian, but it's bigger and weirder and I don't know, much more kind of bizarre and unexpected than any. I don't know. It was a real surprise when they finally found the rest of the skeleton. For years and years, all we had was the arms, and there was all this speculation about like what did the rest of the animal look like. It has these gigantic, remarkable arms, and I love this juxtaposition here because you can see the size of its arms compared to the arms of T-Rex beside it up there. Pretty extraordinary contrast. So yeah, people wondered, is it some sort of gigantic mega predator? Or is it just like a giant ornithomimosaur like Gallimimus, who's got very similar arms? In fact, this is lovely because we can actually see some of the similarities here. See how the fingers are so long and slender on Gallimimus right there? And the claws are relatively straight, they're not super curved. Just kind of elongate.
But the paleontologist field is now what we understand. On the contrary, we stretch
also,
our
all
understanding of the scientific in the
all
universe.
three of the fingers are of relatively, same length, very similar length. It's a characteristic of ornithomimosaurs. So yeah, the kind of most plausible hypothesis is that, yeah, Dinochirus is just a large ornithomimosaur. And it turns out, yes, and it's very different from other ornithomimosaurs in some really, really interesting ways. So I recommend you look more up about this animal, Dinochirus. It's pretty remarkable. And watch that video if you get a chance, the one that I made, kind of telling that story. Pretty neat. Also featured in Prehistoric Kingdom and in Prehistoric Planet. So check those out too if you've not done so yet. Really cool stuff. Really, really cool stuff. Yeah. Yeah. And thank you. New people who followed. I'm seeing people talk about that in chat. I appreciate that very much, and welcome to Paleontologizing. It's great to have you here. Yeah. All right, next up, let's take a look at our Allosaurus here. Now that looks very, very familiar. Is this? It is! Holy cow! This is Big Al. This is a cast of Big Al right here. Check him out. So some of you are already familiar with Big Al. I've talked about him a lot on this channel before. I have a cast of one of his claws in my office. So yep, it's that one right there. I'd recognize that anywhere. His left digit 1 claw, his thumb claw, right there on his left hand. But yeah, Big Al was profiled, featured, starred in the Walking with Dinosaurs special called The Ballad of Big Al. So he is really, really special, not for being particularly large, because despite his name, Big Al is not a very large Allosaurus. But he's remarkable for being very, very well preserved, and for having some amazing healed injuries. And I can actually point some of those out. So look at his rib cage right there. Not these ribs here, but on the other side. You see a big weird lump on one of those ribs back there? That is a healed injury. So his rib was broken, and then it healed in a really weird kind of blobby way. That's what we call a pathology. That's an injury from the animal's life that's preserved in its skeleton. And he's got so many of these. So let's see if we can spot some more of them. He's got some weird stuff going on his back right there, that vertebra. See how it looks all scraggly? Right over here, too. He's got, I think he might have some busted up tail verts, too. Some caudal vertebrae. Well, I'm not seeing them. He's got an injury to his hand, which we can't really see from this angle, I don't think. Not the way I would like to. But yeah, he's got some additional cracked ribs that are kind of more subtle on this side. Cracked and then later healed, but the big injury, I wish we could see it more clearly, is on his middle toe on that foot. So look right here, look at his left foot, look at the middle toe and see how that all looks normal. And now look at that on the other side, see that gigantic lump right there? That is a broken toe bone. And that is probably the injury that killed him. He never reached full adult size. Like a lot of dinosaurs, he lived fast and died young. And that's probably the injury that prevented him from hunting and led to his death. Yeah. If you've not seen it, check out the Walking with Dinosaurs special, Allosaurus, The Ballad of Big Al. You see his life kind of dramatized in that. It's very good. I think you'll like it a lot. It's probably my favorite Walking with Dinosaurs episode. Yeah. And Orchid Twilight. No, I'm not in Madison right now. I'm in Kenosha, Wisconsin. Yeah. It turns out the museum in Madison was closed today. And this museum, which I was planning to go to tomorrow, will be closed tomorrow. So I just turned them around, and like so many things on this trip, got to play it by ear, you know? Got to roll with the punches. So yeah, Allosaurus. So Big Al skeleton, like it says here on the placard, was nearly complete. MOR 692 or 693, I think it's 693 is the specimen number. I've handled some of those bones before at Museum of the Rockies, where I used to work. It's so cool to see him crouching here on the ground. So, obviously, this is a dinosaur that normally would have a stance like T-Rex, walking around on its hind limbs with its forelimbs in front of it, like you see right here. But here, Big Al is crouching on the ground, and you can see that pubic boot right there. So you've got the 3 bones in the hips, the ilium, the ischium, and the pubis, and they're all paired. So you see there's 2. Got bilateral symmetry right there, so there's 1 bone on either side. That pubic boot right there is the thing that extends downward, and these guys probably rested on that. That would have helped support their weight. And in certain dinosaurs, it is really, really big and robust, like in this Acrocanthosaurus right here, and the Tyrannosaurus over there, whom we'll look at in a few minutes
make a
too.
wonderful difference in promoting the appreciation and understanding of fossil
Super cool.
science.
I know Lenina is a big fan of Acrocanthosaurus, so let's talk about Acrocanthosaurus for a moment here. What a beautiful animal. And I think Acrocanthosaurus is one of those dinosaurs that doesn't get nearly enough attention. It just really doesn't. For how large and charismatic it is, I'm surprised that not everybody knows about Acrocanthosaurus. Like, it's kind of a shame. It is such a cool animal. I was working on a video once talking about the popularity of T-Rex and whether or not that's deserved. And I kind of use Acrocanthosaurus as like a counterfactual to that. Like, what if, let's do a thought experiment, if Acrocanthosaurus had gotten some of the same attention in popular culture as T-Rex early on, maybe that would be everybody's favorite big theropod dinosaur. Yeah, I don't know. Because it is, in a lot of ways, I think, equally as interesting as Tyrannosaurus. Except maybe for the idea that Tyrannosaurus is one of the last of the non-avian dinosaurs, and Acrocanthosaurus is not. It's from the early Cretaceous period. But Tyrannosaurus doesn't have these awesome, cool neural spines coming off of its back like that. Super cool. We're still not entirely sure what those are for. Some people still reconstruct it as kind of a sail, like Spinosaurus is normally reconstructed with. I suspect it's more of like a structural support kind of a deal. Kind of like the tall neural spines on a bison over the shoulders. You know, basically, they've got kind of a fleshy hump there in order to, well, there's all these powerful muscles and tendons attached to that to help hold up that big, heavy head. That's probably what these neural spines are for on Acrocanthosaurus here. Very, very cool. Yeah. Awesome. What was the first dinosaur? See films I'll show you in a few minutes. I'll show you the earliest dinosaur that we have so far. Yeah. But man, I just can't get enough of that. Let's take a look at that skull again real quick, because it is beautiful. I think Acrocanthosaurus has such an appealing skull. It's extremely formidable and yet elegant at the same time. It doesn't have the same kind of in-your-face robusticity as like a T-Rex. It's a little bit more, I don't know. It's hard to describe. Very, very cool. All right. And creatively, Emma, so is the neural spines the only way to tell the difference? No, there's a million differences. Holy cow. So let's point some of them out, because that's a good question. There's a few like super obvious things that kind of jump out at us. So one of them is the number of fingers. Acrocanthosaurus has got 3 on each hand. And Tyrannosaurus famously has 2. Right there. See? So 2 fingers on Tyrannosaurus, 3 on Acrocanthosaurus. Those are just like the super obvious answers. The skull also looks completely different. The hips look different. The vertebrae obviously are very different. Every part of its body is different in subtle ways. To somebody like me, you know, these differences just jump out and just hit me right in the face, you know? Yeah. Because these are members of two different groups of theropod dinosaurs. T-Rex, of course, is a tyrannosaur. It's the last and probably the largest of the tyrannosaurs. Acrocanthosaurus is from a different group. It's an allosauroid, so it's kind of related to Allosaurus here. You can see those affinities in its skull and in the rest of its body, and in those forelimbs. Yeah. I think nowadays we think Acrocanthosaurus might be closely allied with the Carcharodontosaurs, like Giganotosaurus and Carcharodontosaurus. But yeah. And we've got a different kind of theropod over here too. Here is Torvosaurus. That's a cool pose for this animal. Another big theropod from a completely different group. So to the untrained eye, it might look pretty similar to Tyrannosaurus or something like that. But Torvosaurus is a giant megalosaur. So it's from... they really had their heyday in the Jurassic period. Torvosaurus, I think, is the largest of the megalosaurs. Go around the other side so that you can see it properly. There we go. It's got a very different looking skull. It's got different forelimbs. Yeah. It's interesting because this same body plan evolves multiple times. These big, you know, very, very large, two-legged, big-headed predatory dinosaurs. It's a group that we used to call carnosaurs. And some people still kind of use that as just, you know, kind of a convenient term. But yeah, the kind of carnosaur body plan. Great big head, small forelimbs, long hind limbs, and a tail stretched out for balance behind. This is a body plan that just works really, really well, so it keeps evolving again and again. I think this independently evolved, and tyrannosauroids, allosaurs, megalosaurs, abelosaurs, at least 4 or 5 times. Yeah. And each one has like different variations on the same theme. So yeah. So for instance, let's take a look at Carnotaurus over here, who's a nice example of an abelosaur. So this is Carnotaurus right here. And this, of course, is the actual size. A lot of people are surprised. They think it's supposed to be larger, probably because they saw the Disney dinosaur movie where it's like huge in that. It's like 40 feet long. The animal's not quite that big, or at least the one specimen that we have of it is not that big.
The site is also mapped for animals, which helps point the relationship to one another. This brings up
there. I wonder if I can hit that button and pause this video or something. Let's see. We'll watch this in a little bit.
I'm just going to take some notes on these comments right there. After the fossils are stabilized, GPSed and mapped.
There we go. Success. Yeah. Let's see. Yeah, and there you go. Yeah, I've got some Carnotaurus emotes. Very nice. How appropriate. So here's Carnotaurus right here. And this is one of those big theropod dinosaurs that kind of takes the small arms thing to an extreme. They've got ridiculously small arms that don't seem to be good for any kind of functional purpose. In fact, they might be on their way to just losing those forelimbs entirely. Unfortunately, they went extinct before they had a chance to really, do that. But who knows, if they had been allowed to continue to evolve, they may have just lost their forelimbs entirely. Kind of like elephant birds do. Which, by the way, I think is the only kind of theropod that ever completely lost their arms. Anyway, check out how small those forelimbs are compared to their hind limbs. Carnotaurus is a pretty leggy animal. It's like a these long, graceful hind limbs like that. And yeah, it makes you wonder. We only actually have one specimen of Carnotaurus. This is a dinosaur that's only known from one skeleton. It was published on back in the 1970s, I think. Pretty sure Bonaparte published on it. It's a beautiful specimen, but it's the only one. So we need to go out and find more to see if, like, is this animal actually fully mature? Or would it have gotten even larger? And maybe its proportions would have changed during that time. Because anytime I see super long legs on a theropod like this, anytime I see a super leggy theropod, my mind kind of immediately goes, oh, that looks like a young T-Rex. I wonder if this is also a juvenile trait in these animals too. We don't know yet. Yeah. I don't think anybody's done any histo on the original Carnotaurus specimen either, so I don't think we actually have a very good handle on exactly how old it was when it died. Could very well be a juvenile. Or at least a subadult or something. I don't know. So yeah. And they do have those ball and socket arms. Exactly, Golganek, yeah. We'll take a look at that in a minute. Just appreciate how leggy this animal is. Such long hind legs. Very cool. Very, very cool. Super neat. Oh, somebody was asking me about the earliest dinosaur. So let me talk about that a little bit. The earliest dinosaur that we have so far, appropriately, it is named Eoraptor, meaning dawn thief or dawn plunderer. And that is a cast of its skeleton right there. It makes me realize that the Eoraptor skull that I have in my office is too large. I printed it too big. I had to print some smaller ones. But yeah, so that is the very earliest dinosaur we have so far. It's about 234 million years old from the late Triassic of Argentina. It surely wouldn't have been the very first dinosaur, but it's the earliest one that we have so far. We need to find some rocks that are a little bit earlier than that and look for dinosaurs there to see if we can find maybe the ancestors of critters like Eoraptor. Pretty cool. And so it looks like a theropod dinosaur. And shoot, you know what? I said that every dinosaur that we're going to see here is a theropod. There is the exception that proves the rule. Eoraptor, we used to think it was an early theropod. It turns out it might actually be an early sauropodomorph instead. So that's the cool thing about dinosaurs is they start off pretty small and they start off bipedal and they start off carnivorous. All of the earliest dinosaurs that we have are small, bipedal, and carnivorous, including little Eoraptor. So this dinosaur here, we currently think is probably the ancestor of the big four-legged, long-necked plant eaters, the sauropods. So yeah, there we go. Yeah. This dinosaur Eoraptor is one of the earliest known dinosaurs and is a base member of Sauropodomorpha. Yeah. Had a fairly long neck and is the closest ancestor of both sauropods and theropods, making it the most primitive dinosaur in the whole museum. There we go. Yeah. Pretty neat. Yeah. I do wonder if that consensus will change with more fossils, but the only way to find out is going to be to find some more fossils. Very, very cool. Yeah. Eoraptor was small, indeed. Yeah. Small and very cool, if you ask me. And then we've got Herrerasaurus right here, another one of these early meat-eating dinosaurs. So Herrerasaurus, this gets tricky because I don't know if the placard here is going to talk about it, but yeah, Herrerasaurus. There's currently like a debate going on as to whether it's actually a dinosaur at all. So Herrerasaurus is either very close to the ancestors of the dinosaurs, like Eoraptor, or it might be a critter that's just, it could be one of the earliest of the dinosaurs, or it could be something that's just very dinosaur-y, that's just outside of the dinosaur family tree. We're not entirely sure yet. But there's a cast of its skeleton right there. It's got really weird-looking hips, and that's part of the controversy. It's also got weird-looking forelimbs. Its skull is kind of bizarre. We're not 100% sure that Herrerasaurus is indeed a true dinosaur. And it kind of goes to show just how difficult this stuff gets. The earlier you get in time, the closer you get to the base of the dinosaur family tree, kind of the more confusing it can get. Like looking at those gray areas between dinosaurs and non-dinosaurs, you know. So yeah. Anyway, welcome, Mr. Coins. Good to have you here. Yeah. And Alex Vixen, Neosasaurus. We're not even sure if Neosasaurus is a dinosaur either. That specimen is so fragmentary that it's really hard to tell. Again, the earlier you get in time, the closer you get to the base of the dinosaur family tree, the more difficult it is to pick out dinosaurs from closely allied non-dinosaurs. So Neosasaurus from, I think you're right, about 243 million years ago old. It's from somewhere in southern Africa, I think. We're not entirely sure if it's a dinosaur or if it's something else. It's too fragmentary. So yeah. Anyway. And here, we've got Coelophysis. Coelophysis is another one of these early dinosaurs, but nobody really disputes whether or not this critter is a dinosaur. And this is a famous specimen right here, a cast of it. Does anybody know the story behind this? Let me know if you know the story. It's from Tanzania. Okay, thank you. East Africa. Sorry, Alex Dixon, not South Africa. Southern Africa. Yeah. Very cool. So this specimen of Coelophysis, and that video is loud. This specimen of Coelophysis is really interesting because it's got some interesting stuff going on in its stomach there. So for a long time, we thought that Coelophysis was a cannibalistic dinosaur because of those bones found in its gut region. So this is from a site called Ghost Ranch in New Mexico, and there are hundreds, probably thousands of Coelophysis all found in the same spot. Maybe they died together in a flash flood or during a drought or something like that. But yeah, they're everywhere. And there's all these really interesting little bones preserved in the gut cavity of this animal. And it's like, holy cow, those are baby Coelophysis bones. So the idea, like, first, kind of asked ourselves, is this... the people who were working on this, rather, back in the... I think that would have been the 50s? They asked themselves, could this be like, an embryo inside a mother developing? But the bones are too big to be from an embryo. This is something that the animal ate instead. And so since they seem to be the bones of a baby Coelophysis, the idea was, holy cow, these dinosaurs were cannibalistic. They would eat their young, or eat the young of other Coelophysis. So for years and years and years, you would see all of these artistic representations of Coelophysis eating baby Coelophysis, and I don't know, this is in all kinds of dinosaur books and stuff like that. But then, a colleague of mine, I think it was Sterling Nesbitt, while he was working in Berkeley, when I was in high school, he was studying this specimen, and he looked at those little bones right there. And he said, well, everybody's assumed that those were Coelophysis bones from a baby Coelophysis. Turns out they're not. It turns out those are actually the bones of a small dinosaur-like creature, a non-dinosaur that we call a silosaur. So yeah. This creature had eaten a silosaur and not a baby Coelophysis. So yeah, pretty cool. The story might get even more complicated because silosaurs might actually be dinosaurs. Again, I talked about how at the base of the dinosaur family tree, things get hazy. It's difficult to tell who's actually a true dinosaur and who's not. Silosaurs are... Most paleontologists agree that they're probably not dinosaurs. but they might actually be ancestral to the bird-hipped dinosaurs. That gets into like Pisanosaurus and all of those guys, widely considered to be like the earliest ornithischian. It might actually be a silosaur. I don't know, it gets confusing. So we need more fossils, and we need more people working on them to figure out what's going on exactly at the base of the dinosaur family tree. So yeah. Anyway. How do people jump to these conclusions, Lenina? We're working with limited information, and I don't know, especially in like the early 20th century, there's a lot of gross speculation about dinosaurs, not necessarily based on much evidence. Nowadays we try to be more careful, but
1,000 bits to make a wonderful difference.
Paleontology was still a fairly new science back then.
Understanding the fossil science there.
All right, so we walked right by the Ceratosaurus here. Didn't even pay him much attention, which is a shame. Ceratosaurus has probably got to be one of my favorite dinosaurs.
I've got a lot of favorite dinosaurs, if you're not aware, I guess. This is one of them. This is a smaller, kind of juvenile Ceratosaurus. And this is from Bone Cabin Quarry in Wyoming. And I think this is the same one that we saw at the Museum of Ancient Life in Lehi, Utah, last summer. Wait, and Mr. Coin says, what do you think about this? They would eat the young and others, but only the sick ones are ones that got left behind. I mean, yep, a lot of animals work that way, sure. But it turns out that with Coelophysis, those weren't, it didn't eat a baby Coelophysis. Those bones are from a different kind of critter. Yeah. Anyway, Ceratosaurus right here. Some of you will recall that I decided to dress up as Ceratosaurus last Halloween. You should check out the Instagram. So I sculpted and 3D printed a Ceratosaurus skull like this, because I kept encountering this dinosaur last summer all over the place, and it's so charismatic. It's got those cool horns on its head like that. That's what the word Ceratosaurus means. The name means horned lizard. So I thought, yeah, this is going to be a perfect dinosaur to dress up as. So I dressed up as a Ceratosaurus skeleton for Halloween. Again, check out the Instagram page if you want to see that. But yeah. So the cool thing about Ceratosaurus, one of the cool things about it is that it's a big predatory theropod dinosaur that lived at the same time as at least two other big predatory theropod dinosaurs. So Ceratosaurus lived alongside Allosaurus over there, and Torvosaurus right behind it. So we've got three big predatory dinosaurs all living in the same time and the same place. And so the question becomes, how are they doing that? How are they all coexisting? Same time, same place. Are they all kind of doing different ecological jobs? Kind of like on the African Serengeti today, you've got three different types of big cats, all in the same kind of geographic area. You've got lions, you've got leopards, and you've got cheetahs all in the same place, each kind of doing a slightly different job. Is that what's going on with these big theropods in the Morrison Formation 150 million years ago? I don't know. We don't really know yet. We need to work on that some more, figure that stuff out. So yeah. Cool stuff. Yeah. And we have an ostrich right here. They're one of these beautiful theropod dinosaurs. And the skeleton of what looks like a chicken right there. Yeah. Very cool. Somebody pull up the turkey command. Do ! turkey. So I did a skeletal diagram of a turkey next to a velociraptor showing a lot of these similarities. Feel free to, print that out and share it with your friends and family or whatever, because I think it's pretty cool. But yeah, you can spot a lot of those similarities between a chicken and something like Gallimimus or Tyrannosaurus or Acrocanthosaurus. In fact, right there, what is that little kind of shallow V-shaped bone in between the coracoids, like in the chest of the T-Rex there? Does anybody know? Who can tell me what that is? Or oh, they don't have it in
Velociraptor, they should. That's missing.
Yeah.
What is that weird kind of U-shaped or shallow V-shaped bone in between the coracoids? Who could tell me? Yeah, that's the wishbone, indeed, and the piece of the furcula. There you go, Larry.
So dinosaurs, theropod dinosaurs, had wishbones. That's where birds got that from. You don't see that in any other animal alive today, except in birds. And the only other creature you see that in the fossil record, is in theropod dinosaurs. It's one of the ways that we can tell that birds evolved from dinosaurs. That and a million other features of their skeleton. And the fact that theropod dinosaurs had feathers, which no other animals have, except for birds. So yeah, pretty cool. Pretty cool. Right there, we've got Hesperornis. We've talked about this critter before. Hesperornis is this really cool, weird, flightless bird that lived alongside the dinosaurs. And it's got these long limbs, long hind limbs for paddling. It probably would have kind of kicked its way through the water, kind of like a modern... Who is it who does that? Is it grebes? Or is it loons? I forget. But they've got kind of sideways facing legs. And they can't really walk very well on land. They kind of have to scoot their bellies along. That's exactly what these guys are probably like. But look there in the beak. Do you see something interesting and pointy going on there? Those of you who saw the stream yesterday, remember talking about like the loss of teeth in birds? This is one of those birds that actually has true teeth. So, birds of course evolved from dinosaurs like this that had big, impressive teeth. And yeah, these birds are kind of they've got that trait held over. They still have teeth like that. Later birds end up losing their teeth. In fact, when the big asteroid hit 66 million years ago, the only birds that really survived that event are the ones that were toothless. I think it was because those happened to be the birds that were smaller and kind of more adaptable ecologically. They could feed on things like seeds, and they could live in little hollows in trees and stuff like that and kind of wait out the disaster. So birds like this end up going extinct, like Hesperornis there. It's a really cool ocean-going bird. This is one of the few true ocean dinosaurs, you could say.
Yes.
All those critters that you normally think of as being ocean dinosaurs, if you're new to this channel, things like plesiosaurs and mosasaurs and ichthyosaurs, none of those guys are dinosaurs. So I get people asking me about that all the time, like, oh, what's your favorite ocean dinosaur? And I always have to tell them, well, probably Hesperornis. Because those other critters you're thinking of are not actually dinosaurs at all. But this is a true ocean dinosaur right there. Pretty neat. Pretty neat. Yeah. And holy cow, thank you, Orchid Twilight. Dual 10,000 bits? Holy cow, Orchid, thank you. I don't even know what to say. Orchid, that is amazing. A Tyrannosaurus-sized thank you to you, Orchid, for your generosity. Thank you for supporting me and supporting this community. That is amazing. Pretty awesome. So this Tyrannosaurus you see right here is Stan. So you see casts of Stan. Stan is a nickname for a particular Tyrannosaurus specimen. Unfortunately, he was dug up by the Black Hills Institute, which is like a commercial outfit, and they ended up auctioning off his skeleton, even though it was supposed to be held in the public trust after publications were done on him and everything. So the original is now belongs to some wealthy person who knows where. I think maybe in Dubai or something, I forget. But anyway, so every time I see Stan, it's like, yeah, there's a little bit of heartache there, But yeah, Tyrannosaurus, pretty cool animal, and I love that that's the one that kind of greets everybody as they walk in. Very, very cool. Now let's take a look at this video real quick. I think that's going to be cool. Use this to cheer us up. Paleontology for a day. Let's check this out. Carthage College and the Dinosaur Discovery
Despite
Museum.
popular culture and the public image, paleontology can be difficult, unglamorous, and at times seemingly boring. But with a good dose of patience, paleontology can be rewarding, fun, and very exciting. Carthage College paleontologist Dr. Thomas Carr, along with student crews and Museum Curator of Education Chris DeSantis, have traveled out to the Hell Creek Formation in Montana. This short film captures part of their real-life search for dinosaur fossils and shares what a day of paleontology is really like.
I bet you that they're out near Ekalaka in this.
Paleontology is the scientific study of life in the geologic past, especially through the examination of animal and plant fossils.
We have been waiting a full year to go back.
To go about understanding fossils, we need to first dig them up out of the ground so that we can study them.
Normally, this is a very long and tiring process. But lucky
Can you hear this okay, everybody? Is the audio okay?
The Scotland student crew on a few digs. So the hard work is already done. And in this short film, we will share some of the experiences we go through on a typical dig.
Now we can finally get onto the field. This is a very significant moment for us because we can actually do what we've been waiting to do for a
Yeah,
year.
you gotta get those permits, you know, from the BLM, Bureau of Land Management.
And because the Dinosaur Discovery Museum is so focused on dinosaur evolution, you'll see those are the fossils we are after.
I have learned a number of things from Dr. Carr on these digs. One is that we have to start our day early because it gets way too hot to work in the afternoon.
Not always. Well, you just gotta have shade tarps.
We also have to leave camp with everything we need, so there's a lot of prep work to be done. When we have all of our equipment, along with plenty of food and water, we are ready to head out for a busy and safe day.
There are three major parts of a dig. The first is prospecting.
And look at that. Prospecting is looking around or carefully observing your area for bone-like objects. Walking around a hillside, you look for scattered or possibly just a single bone or fragment.
There you go. So that's what it looks like oftentimes. So there's what we call float. It's bones just there on the surface.
Further up.
So you'll follow that up the hill and try and figure out where they're weathering out from.
Closely. You carefully dig around the object, exposing it without harming or disturbing it. That's rough. That's rough.
Well, I might have found something else. It looks exactly the same. Usually, this growth won't be hanging on to a rock. It'll be hanging on to a bone. So, I'm not sure. I think I should...
Yeah, you gotta be careful of those roots in the field.
Take a look at this.
They do tend to kind of splay out over the surface of bones. Occasionally they'll plunge through the bones, and that's really bad.
Yeah, I think so.
Sometimes plants are our enemies in the field.
This is usually the indication to me. There's this growth out here. Yeah. It's a piece of bone. It's definitely a piece of bone. Once something is identified as a bone, we start a process called quarrying.
Quarrying is digging around the fossil to expose it and to see if there are other bones around. There are very important parts of this process, including...
So they're just doing overburden here. They're clearing stuff away really quickly. When they get down to the bone layer, they'll be a lot more slow and a lot more precise.
Precisely where the bone was found. Then, as much dirt as possible needs to be removed without disturbing the bone. We then apply coats of liquid plastic.
That's Vinac. Yeah.
The site is also mapped. with
Not using a mustard bottle there.
bones, which helps pinpoint their relationship to one another. This brings up a good point. During a dig, we log or take notes on everything. It is important to have documentation on all aspects of fossil digs.
I'm just going to take some notes on what we did yesterday. After the fossils are stabilized, GPSed and mapped, they are wrapped in a messy but sort of fun process called jacketing.
Yeah.
Jacketing ensures that each specimen...
And I miss plaster jacketing. We'll be doing a lot of that this summer.
We encase the bone inside a plaster jacket. When the top half is dry, the fossil is rolled over and the jacket is completed.
That's called the flip. That's a crucial moment when you flip it over.
And is then ready for transport.
Some jackets get very heavy.
We had to carry this one back in the evening to avoid the heat of the day. The step-by-step procedure of a typical find, prospecting, quarrying, binacking, mapping, jacketing, and finally extraction, aids in not only preserving the bones, but preserving and understanding what the bones and the location can mean.
So I'm definitely ending on a good note. It's pretty exciting. I mean, anytime you find any little thing that's exciting, but being in the same grid with the portion of the femur we found last year, this is pretty exciting. Pretty exciting.
After long hours of digging, it's time to call it a day. We make sure our fossils are covered to protect them from the weather so we can pick up where we left off. We grab our personal items and head back to camp.
It's a pretty nice summary of how it actually works. Yeah.
Patience is key. And experiencing paleontology for a day hopefully demonstrates that patience has its own reward. Great first step. And when a discovery is made, if the work is done and the right steps taken, that patience pays off.
Hey, science is not boring. Check it out.
Very true. Very true. Yeah, pretty cool. So yeah, I've never actually done any real field work with Thomas Carr himself, but I've worked with people who've worked with him, and it's a decent chance I might actually run into him later in the summer, especially if I go down to Ekalaka at some point. But yeah, so he runs a pretty small crew, like a lot of the crews that I've been on, and cool stuff. I hope you enjoyed that. Yeah. But yeah, anywho, let's go ahead and scoot back around and we'll check out one of my very favorite dinosaurs who we've been avoiding so far. Let's see here. There we go. Past all of these guys.
And there's a lovely juvenile Ceratosaurus right there again. But more after somebody bigger. Who could tell me who this is right here?
Paleontology is a scientific study of life from geological past, especially through the examination of animals and fossils.
Any guesses?
Normally, this is a very long and tiring process. But lucky for you,
who is that, everybody? That is Suchomimus.
And this is actually the first time I've ever seen a Suchomimus cast. Like, you know, a full skeletal mount like this in person. So I am pretty excited about this. Look at those long, slender, crocodile-like jaws. Look at those many, many teeth in those jaws, all conical, all mostly lacking serrations. Look at how narrow that skull is from side to side. The name Suchomimus means crocodile mimic, and it's because of those long, slender, crocodile-like jaws. Really reminds me of something like a gharial, or maybe a false gharial or a slender-snouted crocodile. Like an Orinoco crocodile or something like that. Super, super narrow jaws side to side. Very cool. Yeah. And so Suchomimus is one of the dinosaurs that I'm working on for a current publication. Looking at their feeding ecology, trying to figure out how they would have caught fish. Because there's a good consensus that these were fish-eating dinosaurs. That they had special adaptations for catching and eating fish. That's what they did as theropods. Like, these are specialized theropods, specialized for catching and eating fish. And I'll point out some of those different adaptations here. First of all, are those super narrow jaws. That's something that's characteristic of fish-eating animals. Like, say, a slender-snouted crocodile, like a gharial. And they've got many teeth, especially for a theropod. They've got more teeth than almost any other theropod dinosaur. And those teeth unlike most theropod dinosaurs who have kind of almost knife-like teeth, almost like a steak knife, they're kind of compressed from side to side and they've got sharp serrations on them. Spinosaurids like this do not. Their teeth are kind of conical in shaped. They're kind of cone-shaped, and they don't have those serrations for like slicing through flesh. Instead, their teeth are conical for like punching through the bodies of fish, we think. The teeth are very much like those of crocodiles, who mostly eat fishes as well. So pretty cool. And then check out these forelimbs here. I mean, holy cow, look at those. Look at how robust these limbs are. This has everything to do with the paper that I'm working on. I can't talk about that yet, but I can just tell you to marvel at these claws and the robusticity of those forelimbs, just how robust they are. Very, very cool. And then what's that little bone right there in the middle, too, in the middle of the chest? Some of you already know what that is. Shout it out. What is that? Oh, did we get some new followers? Welcome, welcome. Shoot, I should do a quick intro real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. I study these guys. I'm working on a paper on Spinosaurids right now, getting that ready for publication. So it's so cool to be able to see this here in this museum. Here on Twitch, I stream science content. I talk about fossil science. My whole point here is to show you what it's like to do paleontology, to give you an inside peek into how fossil science works, and share my passion and enthusiasm with you, answer any questions you might have, and yeah, I'm here to be kind of your personal ambassador to paleontology, with a strong focus, of course, on dinosaurs. So right now, I'm on this big road trip going all across the American West, visiting different museums and field sites, talking with other paleontologists, and streaming whenever I can. Later in the summer, I'm going to be doing some field work. Hopefully I can stream an actual dinosaur dig, show you what it's like to dig up dinosaurs. But for right now, we're touring these different museums. So right now, I'm at the Dinosaur Discovery Museum in Kenosha, Wisconsin, which is definitely worth a stop if you're ever anywhere near here. Admission is free, which is nuts. I'm going to have to give them a donation on the way out, because or buy some stuff from the shop, because this has been really awesome, and it definitely deserves our support. So yeah. That was indeed a wishbone that you see in the animal's chest right there. The furcula, that kind of slender, shallow V-shaped bone. It's the furcula, just like you have in modern birds. So modern birds are, of course, theropod dinosaurs, like all the ones that you see here. That's why we also have birds among this group. But yeah. Pretty neat. But just look at that skeleton. Holy cow. Look at those elongate vertebrae right there. Pretty interesting. Almost reminiscent of those of Acrocanthosaurus. I just can't get enough of Suchomimus here. It's such a cool animal. Tiny Blub says, what is the most difficult journal to get your paper published in within your field? Probably Nature. Either Nature or Science. Yeah. Because they only take certain kinds of papers, too. I mean, you might have a really, really interesting paper that's really well done, but if they don't consider it, like, flashy enough, they're not going to publish it. But yeah. Here, let's go take a look at this critter from the other angle. Suchomimus. Wow, that rib cage is much bigger than I would imagine it to be. Like, this is a big dinosaur. I know Spinosaurids in general have a reputation for being very large, especially Spinosaurus. But this one too, Suchomimus, is it's impressive. It really is. Very, very cool. So here, the light-colored bones are the ones that we actually have represented. Or no, sorry, it's the other way around. The dark-colored bones, there we go, are the ones that we actually have
Or is it light colored? Shoot. The skull is throwing me off there. No, it's got to be the dark colored ones. Dark colored bones are the bones that we actually have. The light colored ones are the ones that are sculpted. We're going to fill in the gaps there. Nope, that's not right because the furcula is light colored. We have a Suchomimus furcula. It's the light colored bones are the ones that we have. Shoot. Yeah, although we've also got lower jaws. It's confusing. That is confusing. Anyway. Pretty impressive critter, Suchomimus. Pretty extraordinary. Yeah. And Golganix says, appreciate the inclusion of that ostrich and chicken amongst the other theropods. Yeah, Golganic. Isn't that cool? Very, very cool. Super neat. I'm thoroughly enjoying being here. I hope you are too. Anyway, how is everything supposed to be paid for, says Anima Confusa? Oh, this museum is associated with Carthage College here in Wisconsin. So I think some of the funding comes from the university. And this is a municipal building right here, as I understand it. So I think some of the budget also comes from the city, too. Which is cool. I mean, I think if you can make a museum free to the public, you absolutely should. If you can find other ways to fund it other than through admissions, then you absolutely should. That's something that I believe very strongly in. I think museums should be accessible to everyone. So if you have to charge admission, you should at least have some kind of program, for people who might need some help with that, I think it's really sad when economics can be a barrier to entry for people into museums, So yeah. You think the discussion involved the journal Nature? Oh, yeah. Well, we're not going to talk about journal politics and everything right now, but I don't want to go off on a big rant about something so aggravating while I'm here in such a cool place. I'm going to stay positive for right now, but ask me another time, maybe. And we can talk about the economics of publishing and that kind of thing. But for right now, I am thoroughly enjoying this. And here from this angle, you can see that Torvosaurus skull. That's such a weird pose for that animal, kind of scratching its head on the ground. But really weird and cool. And Lenina, holy cow, the Science Museum of Minnesota yesterday, that was like $40 for me to get in. It was like $35 for admission, and then it was like $10 for parking, and I don't know, that was expensive yesterday. It was a lovely museum, but man, and you can see why, I don't know, people who are not financially fortunate, or I don't know, you can see why museums mostly cater to wealthy people, and more working class people are often suspicious of museums when it works like that, That's why I like when museums are free. Recall all the dino names. Wait, what do you mean, Arca Twilight? What? And what's the actual spelling for Suchomimus? Suchomimus. Suchomimus. Like you see on this placard right here. Yeah. Suchomimus. Right there. Yeah. People over there having a discussion about evolution. I'm kind of listening in.
And full Alamosaurus skeleton? Are you sure, Hugin? I don't think there's a full Alamosaurus skeleton anywhere in the world, unless you're talking about a cast. Yeah, Alamosaurus is not very well known, unfortunately. Yeah. The guy's talking about irreducible complexity, which is like a classic creationist talking point. I don't think I'm going to get involved, but yeah. But yeah. Anyway, just admiring this critter. Sorry if I'm just kind of giddy being here next to one of my study animals that I've never actually been in the presence of before. Pretty cool. Yeah. The original bones, of course, are in Niger at the Gadafoa Museum, I think. But there's been a number of different casts that have been made, and so lucky to be able to see one right here. Yeah. Very cool.
Again, this crazy pose on the Torvosaurus here.
I really like this. It's like, it would have been nice if they could turn a little bit more so you could see the head more properly, but it is nice to be able to see the top of the cervical vertebrae there.
That's neat. And have that forelimb contact in the ground like that. It's a very dynamic pose.
You know, I kind of wonder whether...
Oh, the skeleton is mounted in a feeding pose, it says. Yeah, okay. I kind of pictured her
putting her ear down to the ground to listen to her embryos inside of her eggs or something like that. Because we actually have nests of Torvosaurus from Portugal, which has told us a lot about the reproduction of these dinosaurs. So you know that these guys, or gals I should say, if we're talking about female Torvosaurus, they laid their eggs in earthen nests, probably covered them with vegetation and with a little bit of earth, and that would help incubate the eggs. So they didn't sit on their eggs like a modern chicken or something like that, or like oviraptorosaurs down there would have done. These guys, or gals, would have constructed earthen nests, kind of like modern crocodilians do. Alligators and caimans will do that. They'll make nests out of vegetation on the riverbank. But yeah, and no more dragging tails. Exactly, Lenina. Yeah. No dragging tails today. Pressure's up. Yep, this is lovely. Yeah. It's funny, even when the animals are crouched down like this, the big animal, the Allosaurus, the tail is still held aloft, as it should be. Very cool. And yes, most museums have changed their displays to reflect that. It's difficult because some super old displays are built in such a way that they can't really be changed. Especially if you have actual fossil bone that has metal rods drilled through it, like some of the really old displays from the early 20th century. But yeah, in just about any modern museum, you'll have dinosaurs in more modern poses. Upright stance, tails held out straight behind them for balance. Like this Gallimimus here, just beautiful. Yeah, super impressed. So many big theropod dinosaurs crammed into such a small space. It's extraordinary. It's very, very cool. Yeah. Oh, and yeah, I can show you the Carnotaurus ball joint. Let me go over there and show you. That's the Tyrannosaurus here.
There's those gastralia, those belly ribs. I would put them at a bit more upright angle, but maybe that support there is saggy. Here's our Carnotaurus over here, huh? And check out that ball and socket joint there by the forelegs. So there's the arm, super small arm. This arm
Is like half the length of my arm, even though this animal is so much bigger than I am.
But check out that super well-developed ball and socket joint there between the arm and the shoulder. Very cool.
So some of you have already seen Prehistoric Planet, that wonderful BBC documentary series, David Attenborough. The Carnotaurus that shows up in that has got, I don't know, a very peculiar use for its ball and socket arm joint. Check it out. I think you'll really like it. You can find it on YouTube as well. Just search Carnotaurus arms. That's how you spell Carnotaurus right there. Carno, like meat, and Taurus, like a Ford Taurus.
There you go. Name means meat bowl, or meat-eating bowl, on account of super cool horns on the animal's skull. A lot of people are surprised to see the Carnotaurus. It doesn't have a huge head compared to its body. Like its skull is not the hugest, which is really interesting. It's got this big, thick neck like that, really long, lanky legs, and its skull is very robust, but not super large. So it kind of makes me wonder what they're doing. I wonder if these guys were like specialist predators of small, fast ornithopods or something like that. Hence the long legs for sprinting after them. And very robust head. Maybe they would have run head first into those animals in order to catch them. Who knows? I don't know. Wildly speculating at this point. But yeah, very cool. But yeah.
The global and serious game
Neat
of
stuff.
paleontology.
Smaller head like a cheetah, says Lenina. It's an interesting thought. Yeah. For cheetahs, the mechanism by which they catch their prey is obviously they run after it, and then they trip it with their forelimbs, and then they go and just kind of do a swift bite to the neck. In order to cut off the air supply. For something like this, it's kind of easy to imagine a dinosaur like this, like Carnotaurus, chasing after a small little thescelosaur or something like that. A little fast, beaky, plant-eating dinosaur. And just running into it head first. Maybe even headbutting it, or maybe running into it with the jaws open to kind of trip it up that way, and then seize it with those jaws and maybe just lift it up into the air using that really powerful neck. Yeah. I don't know. Again, speculating. Yeah.
Real dinosaur.
Hey, Kalma, how you doing? Welcome. Yeah. Great to see you. Carnotaurus sure couldn't trip anything with those arms. Yeah, Elias, those arms are not useful for anything predatory, it seems. It's so strange because these are such puny little arms, and yet that shoulder joint there is so well developed. So maybe they were used for display like they show in Prehistoric Planet, or maybe there's something else going on there. It's hard to say. Yeah. Very cool. Very cool. I hope that guy doesn't turn the video on again. This thing's so loud. Oh. Oh, he did turn on the video. Oh well. We'll be wrapping things up here pretty soon, I think. Yeah, where in Wisconsin are dinosaur fossils found? Nowhere, unfortunately. At least not yet. I would actually be pretty surprised if we ever do find dinosaur fossils here in this state. geology just isn't right for it. And there's not a lot of exposed rocks in Wisconsin as well.
Paleontology is the scientific study of life in the geologic past, especially through the examination of animals and fossils.
Anyway, no dinosaur cheese today. There you go. Well, very, very cool. I think we've seen just about everything there is to see that I can stream, at least. I'd show you the laboratory downstairs, but we don't get any signal down there. Let's go ahead and go outside, and then we'll sign off. Yeah.
This is a very significant moment for us. We can actually do.
All right. Okay. No Wi-Fi that I know of, Skullgun. No. There we go. Yeah. Oh, what a lovely plaque. Kenosha Public Museum. That is lovely. It really is. These are some of the same dinosaurs that we saw at Dinosaur Park in Rapid City. Stegosaurus, Tyrannosaurus, Apatosaurus, Protoceratops, Trachodon, Edmontosaurus, Triceratops. In the same poses that we saw there. Very cool. So this was the Dinosaur Discovery Museum in Kenosha, Wisconsin. Hope you enjoyed that, everybody. I know I did. And holy cow, they even have a dinosaur right there on the facade. In form of an eagle. Very cool. Well, let's go right over here and anybody have these like wooden dinosaur puzzles, dinosaur skeletal puzzles when they were a kid? I know I did. That's cool. Anyway, let's go ahead and start wrapping things up here. Let's see who else is live on Twitch right now. And we'll see if we can pay a raid to another science person. Let's see. Oh, Evo Lazzi is on. Yeah, why don't we go raid Evo Lazzi? I'll hand you over to another scientist right now, and we'll see what he is up to. So let's do that. Over to my channel, go to the chat, and then
America loses. Correct.
Raid Evo Lazzi. There we go. So tomorrow, everybody, with any luck, I'll be streaming from the Museum of Geology at the University of Wisconsin campus in Madison, Wisconsin. And then after that, maybe after a few days, I hope to be at the Burpee Museum in Illinois. And that might be my last museum stream for about a week. We'll have to see. Might be my last stream for about a week. We'll have to see. I want to take a little break in the middle of this trip. So it might be a fine time to do that before I head back west and then go start digging some dinosaurs in late July. Anyway, everybody, thank you so much for another wonderful stream. I hope you had a great time, and I hope you'll join me again tomorrow for another fun museum stream. Should be pretty cool. Thank you, everybody. You take care. Thank you for all of your financial support, especially you, Orchid Twilight. Holy cow. And you take care of yourselves. I will see you tomorrow. All right. Bye-bye, everybody. See you later.